When resistors are connected in parallel, the total current entering the junction splits between the branches. The current divider rule helps us calculate how much current flows through each branch. A parallel circuit is a circuit where components are connected in different branches, as we can see here. Yeah. But at the same time, they're connected between two nodes, as we can see clearly here. Because there are multiple branches, okay, the current has more than one path to travel. So when it reaches a junction, okay, it splits between the branches. Okay, as you can see here, we have I total, okay? So I total reaches this junction right here, as we can see, this one, and it splits into I1 and I2. This over here is typically what a junction looks like, okay? So a junction is a special type of node where current splits or combines, okay? Usually it means where three or more branches meet. To understand the current divider rule, first we have to understand what happens in a parallel circuit when current reaches a junction. Okay, so let's start with the basics here, okay? So I total would be equals to I1 plus I2 in a parallel circuit, since the current splits. Okay, so for example, let's see here. With I total is 11, we have I1 is 7 amps, and we want to find I2. Okay, how would we find I2? Okay, we would take I total, okay, minus I1, which is 7. Okay, and that will give us I2, which is 4. So I2 here would be equals to 4 amps. Another very important piece of information to know is that the way current splits between the branches depends on each branch's resistance. Okay, so the more resistant the branch is, the less current goes in the branch. Okay, so let's say R1 had more resistance than R2. Where do you think naturally the current would be more in? Or, you know, like which branch would have more current? Okay, the branch that has more current would naturally and always be the one with the less resistance. So here R2, or this branch right here, would have more current than this branch right here. So I2 would be greater than I1 in this case. One thing to mention before I explain this is that this formula only applies to when there is two resistors in parallel. So let's say you wanted to find the value of I1, and the only values you had, the known values, were R1, R2, and I total. Okay, so there is a special formula you can use to calculate I1, which is written down here. Okay, this formula is basically I total times the resistance parallel to the branch of the current you want to find. So in this case, it's R2. Okay, divided by the total resistance in the parallel branches. Okay, so let's say I total was 8 amperes. R1 had a value of 4 ohms and R2 had a value of 7 ohms, and you wanted to find I1. Okay, so I1 equals, okay, the total current, 8, times, okay, the value of the resistance opposite to the branch of the current you want to find, okay, which is 7 ohms, divided by the total resistance, which is 11. Okay, and this will give us a value of 5.0 9 amps. Okay, and here what we can do to find the I2, since we have the I1, okay, we can just do 8 minus 5.09, and that will just give us 2.91 amperes. Okay? Another case you could have is when you have 3 or more resistors in parallel. Okay, as you can see here. Okay, so let's say you wanted to find one of the currents in one of the branches. Okay, let's say you wanted to find I1. Okay, what would you do in this situation? So you would use this formula right here. Okay, this formula, how do you use it? Basically, you multiply I total by 1 over the resistance of the resistor in the same branch of the current you want to find, which is, in this case, if you want to find I1, it's R1. Okay, and then you would divide that by 1 over R1 plus 1 over R2 plus 1 over R3. And let's say if you had another resistor, which was, let's name it R4, you would also add 1 over R4. Okay, and it continues, as many resistors as you have. Okay, so now let's do an example. Okay, so let's say I total is 12 amps and R1 is 5 ohms and R2 is 8 ohms and R3 is 2 ohms, okay? And we wanted to find I2, okay? How would we find I2? So, we would use the formula right here, okay? Which is I total, which is 12, multiplied by 1 over 8 ohms, because it is the resistance of the resistor in the same branch of the current we want to find, okay? So it's 1 over 8 divided by 1 over 5 plus 1 over 8 plus 1 over 2. And then we would find I2. Now, let's say you wanted to find I3. Okay, so this is a special trick that you could do, which could make your life easier. Okay, so basically, what you would do is you would combine R1 and R2. Okay, how would you do this? Okay, so if you remember, 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3, and it goes continuously, okay? So you would do that, and then you would apply the same formula, the special one for the 2 resistors in parallel, which was I total times, in this case, we would name this, let's name this R1, and we would name this R2, like this one, R2, okay? So this one would be R1 times R2 plus R1, and that would be way easier than, way faster, way simpler than doing this one right here. Okay, so then let's try this method using this example, okay? So first off, we'll combine R1 and R2 by using the formula. So we go 1 divided by 1 divided by 6 plus 1 divided by 8. And that would give us 24 divided by 7. Okay? Now, we're going to use the special formula we talked about, the one with the 2 resistors, okay? So which was I total, which is 12, times we want to find I3, so we're going to use this one right here, the one we combined, 24 divided by 7, divided by R total, which is 24 divided by 7 plus 2. and that will give us I3. I3, using this method, gave us 7.6 amps. Okay, let me just calculate the I3 using this formula right here that I explained to you earlier, just to prove that both of them work. Okay, so 12 amps times 1 over our x, which is 2, divided by 1 over 6 plus 1 over 8 plus 1 over 3. And that would also give us a value of 7.6 amps. So that concludes that both methods are correct and they both work. In conclusion, okay, in parallel circuits, the current splits at a junction and divides between the branches depending on each branch's resistance. Okay, the current divider rule, as I explained earlier, helps us calculate exactly how the current is distributed in the circuit. Thank you so much for watching.